Hello everyone, my name is Dhruv Patel, and today I'll be discussing lab report for Lab 1, which is called the charge tapes. We'll be analyzing Coulomb's law and the behavior of the charged particles in excess amount. Now, just to get familiar with the lab assignment, its purpose is to understand and observe the behavior of two charged tapes with excess amount of charge. To help us understand further, Coulomb's law and the principle behind it will help us understand how the particles behave and why they behave like that, but in a more of a mathematical sense as well. All of this is assuming there is no air resistance and when the tapes move and that the entire tape are a singular point. Moving on, looking at the important formulas, this is the Coulomb's law in more of a mathematical sense. Um, that there is an electric field and force by that field around that particle. It is very clearly written as the constant K, which is 1 over 4 pi times epsilon, which equates to roughly 9 times 10 to the power of 9 Newton times meter squared over Coulomb squared. So K times the charge of the particle, which is, in this case is a charge of a proton, which is 1.6 times 10 to the power of negative 19 coulombs, which is also the charge of a electron, but in negative. Um, So K times the charge of an electron divided by the distance squared, and of course we can always square the both the charges because we're multiplying by the charge of a proton and the charge of an electron, and since we're only finding the absolute value, we can just square them, and this will be helpful in our calculations later on. Here is my lab data. I used a 0.2 meter tape that weighs around roughly 0.2 grams. When observing during the experiment, the floating tape B moved about 0.03 meters towards the other tape. I also have found that the force of gravity on tape B, um, which will be used to calculate the force of electric field later on as well. Assuming that the net force is zero and that the surrounding isn't interacting in the experiment, we can see that the ideal force is equal to the force of gravity. We can clearly see the difference in the amount when you use Coulomb's law to calculate the proper force of the electric field. This shows that there must be more charge than calculated on the tape. Some of the observations I made were seeing that I need to handle the tapes with extreme care, as the induced dipoles would cause the negative objects like my hands and the books to be attracted to the U-tapes. Another observation I made was that when the two U-tapes were brought together, they repelled as they had similar charges since like charged like each other. Also, a trick that I thought was interesting was that when rubbing the tapes with your finger, the tapes would become neutral as my finger would take all the charges away from the charge on the tape. On the other hand, you can give something a negative charge, such as a pen or a straw, which then becomes attracted to the tape um, when brought closer. These are some of the questions that were brought up after the experiment. That what if electrons had positive charge and protons had negative charge, and how would the experiment slash observation change? Well, they wouldn't, because we observed that the positive charges attracted each other and the like charges repelled each other, so the tapes would behave the same way as they did normally. Of course, as I discussed before, that I needed to handle the tapes really carefully, as the tapes would lose its charge when my hand would interact with it. This is my GlowScript code that helped me calculate all the calculations that I had before and visualize the scenario as just singular particles. That is the end of my lab report. I hope everything made sense, and goodbye.